We have a very basic rim shader as the foundation of our force field. Together with the time node and a sine wave, we can add a little bit of animation to the rim glow. The center of our force field is a bit hollow, however. It does feel like it needs a bit of texture work in there. Let's add a tile pattern to our force field to give the surface just a little bit more detail. Our goal for this episode will be to add a nice hexagonal texture to the center of our force field. This will create some extra visual interest. And to do that, we'll learn how to use the Tiling and Offset node to affect how a texture repeats and is placed on the surface of 3D geometry. Open up the force field shader graph, and here's our current progress. We'll need to make a little bit of room, so close whatever preview windows you can. I'll just leave the thumbnail under the master PBR node. Remember that the way this works, the emission in the PBR master is producing the glowing color, and the alpha channel is just determining what's opaque and what's transparent. We can import a couple of textures to modify both of these, and if you look at the resources, we should have a couple of PNG files available to you, a hex tile 256 pixels PNG, and a ramp 64 by 256 pixels PNG. The hex tile texture is tileable. If you try to shift it sideways or up and down in Photoshop, we never see a hard seam. The ramp texture is very small and simple. We have a white stripe with a gradient fade on the top and the bottom, and this is seamless in the horizontal direction. If you want to stretch it to any width sideways, it looks like a solid white stripe, and that will be useful later, so just keep that in mind. Import both of those textures into your project, hex tile 256 and ramp 64 by 256. The default import settings should be fine. Now once we have those imported, let's return to our shader graph. And let's add the ramp texture first using a texture node, spacebar or right click, input, texture, texture 2D asset, and let's browse for the default texture, ramp 64 by 256. And let's connect that to a sample texture 2D node to convert it to RGB values. And this should be almost automatic 90% of the time that you're using a texture asset. Let's convert this to a property, and we'll call it scanline texture. Eventually, it will define this horizontal stripe that moves downward through the middle of the force field. Okay, so how do we combine this texture with the Fresnel effect that we already have, and then pass that into the alpha channel? Let's disconnect what we're currently feeding into the PBR master's alpha property, so it's a little bit easier to understand what's happening. So let's just delete this line. Now what we want to do is combine the two textures, the Fresnel effect and the ramp, into one. And remember, the alpha property of the PBR master is typically going to take a black and white image. This will act like a cutout to only expose parts of the colored pixels. If you want to see something on the surface of the sphere geometry, the alpha needs to have some kind of positive value. Everywhere that we define white or 100% is purely opaque. Anywhere that's black or 0% is completely transparent, and every shade of gray represents something in between. So really we just want to add this scanline texture to the Fresnel effect, and we'll do that with a math node. Create node, math, basic, add, and let's connect these inputs. And you can disregard the Fresnel effect's black preview thumbnail if that doesn't show up. It's just not refreshing properly. But when I add them together, you should see something like this. In the add nodes preview, it looks like the sphere has a white ring around it. We want this to connect to the alpha. And once we do that, that becomes our new alpha channel. We have this rim glow, but we've added this stripe running horizontally in the UV space. And that's going to form the basis of the extra fill texture that we're going to put on the surface of the sphere. Now we're currently passing in the blue color from the rim color property into the emission channel. Now that part still looks okay, but because the albedo is just a default medium gray, we're going to get this gray band across the center of the sphere. And that's the general idea, but we don't want the center fill texture to be solid. We want some kind of pattern there instead. We have a hex tile texture that we imported, and we can use that. So let's drop that into our graph. Just like any other 2D texture asset, create a texture asset node, input texture, texture asset, and let's set the default texture to be our hex tile 256. Expose this as a property, and let's rename it to fill texture. Let's connect the texture asset to a sample texture 2D. All this should be second nature to you by now. And this gives us two textures. The ramp will define the scan lines, and the hex tile will be used to apply a pattern within those lines. In order to see the hex tiles in our white band area, we're going to use a multiply. Math, basic, multiply. Essentially, the multiply node will show you an intersection of these two textures. And in our case, it kind of looks like this. The narrow white band and the hex tile only intersect here, leaving a couple of vertical lines. And that looks terrible, but it is mathematically correct. What we want to do is make our hex tile texture smaller and make it repeat. And that will look a little bit closer to what we want. We can do that with the tiling and offset node. So let's shift some of these nodes over to make some space in our work area. I just need to add one more node at the head of the graph. Let's create a tiling and offset node. Create node, and you'll find this under the UV group. Tiling and offset. Drop that into place. This node will always output into the UV port of the sample texture 2D node. So let's connect that. And we want to make sure that we're affecting the fill texture of the hex tiles texture asset. So this node essentially controls how the texture responds to the UV coordinate system. You'll notice that the tiling and offset node has several inputs. The top is a set of UVs that defaults to UV0, which is the default for our 3D model. We can leave that since that's what we want. We want to use the default UVs of the sphere geometry. The other two inputs we do want to change. Those two vector 2s control how the texture repeats and how it's offset in UV space. If you increase the tiling values, let's try 2 by 2, the hex tile pattern gets twice as small, essentially twice the number of hex tiles show up. And if you look at the multiply node's preview window, when I do that, you'll see that we've made the pattern smaller, and you can start seeing the hexes there. When I choose a value of 3 by 3 for the tiling, it looks like this. And that tells me that we can go with larger numbers. So let's try 10 by 10. And now we get a nice honeycomb pattern of hexes where our white band was before. Let's reconnect the result of this multiply into our add node. So just break the previous line and now connect this one instead. Let's add the honeycomb pattern to the rim glow of the Fresnel effect. And now you can see the hex tiles in gray on the master PBR preview. Our alpha channel has that hexagonal pattern built in. Now the gray still comes from the base albedo color. We probably want the hex pattern to glow just like the rim. It's supposed to be some kind of energy field after all. Right now we're only multiplying that rim glow and then passing that into the emission's RGB values. Let's multiply the rim color with both the glow and the hex pattern combined. So disconnect this output from the Fresnel effect node, just briefly. Now when I do that, I get a solid color feeding into the emission. Because the alpha channel has a pattern essentially cutting away the color, we only see the rim glow and the hex tile pattern glowing in blue in the preview. And that should be close to what we're going for. Now if you want to visualize this in our multiply node with the texture that we're currently using, the alpha, you can simply stuff the output of the add into the multiply node. Essentially that will pre-multiply the color before we send that information into the emission channel. It shouldn't really affect our results, but now we can preview it in the multiply node. And effectively we have a rim glow and a little bit of hex tile pattern on the surface of the sphere. Okay, pretty cool. We've learned how to use the tiling and offset node to alter how the texture repeats and fits in UV space. You might want to expose some of these inputs on the blackboard for the tiling and the offset. So let's create a couple of vector 2s. And I'll call this fill tiling. And let's default this to 10 by 10. And let's create another vector 2 called fill offset. And we'll just leave the defaults at 0 and 0. And you may want to reorganize your Blackboard properties if they aren't grouped in the right order. Your fields in the inspector will appear just as they do in the Blackboard. So just drag and reorder these properties as you need. Try to keep the fields that are related together. And then add these fill tiling and fill offset properties to the graph and connect those into the respective input ports. All right, we should be ready to see our shader in the scene. Let's save the asset, unmaximize the window, and let's check it out in the editor. And that's a little bit unexpected. It looks like our default textures did not get filled out automatically, so the whole surface of the sphere is glowing. I'm not sure if that's a bug or a feature with this beta release, but we can fix that. Let's just select those textures in the inspector, edit the material, and choose the ramp image for the scanline texture, and not the hex texture. We want the ramp. And now let's choose the hex tiles image for the fill texture. And okay, that's closer to what we were expecting. Our sphere still has its rim glow, but now it has this extra belt of hex tiles right at the ground. It's centered on the sphere's equator. We have exposed our fill tiling and fill offset properties, and those can affect the look of the hex pattern. So adjust those as you see fit. So if you turn up the tiling to 20 by 20, your hexes now look closer in size, what we're after. So go ahead and play with those numbers. Unfortunately, while our fill offset property does let us shift the texture relative to the scanline, we still need to be able to shift the scanline itself. It would be better if we could move that belt that circled the sphere up or down. And here's a good challenge for you. See if you can use the tiling and offset node to modify the scanline texture. You probably want to create some separate controls for its tiling and offset, just like we did for the fill texture. Another thing that you want to do is make our little scanline texture move. Use the time node to see if you can add some animation. With the correct settings, you can make the whole white band move up or down, just like the scanline of an old video screen. Now that may help to sell the force field as if it were being projected from somewhere. Okay, pause the video, try that out for yourself. When you have a solution, or if you need some help, unpause and continue to the end of the lecture. Welcome back, hope that worked. Essentially what we want to do is create another tiling and offset node for our scanline texture. Create node, UV, tiling and offset. And let's drop that at the front of the graph. We want to connect the tiling and offset into the UV input port of the scanline texture's sample texture 2D node. And now we have controls to adjust the tiling and the offset. The offset in particular will be really useful for controlling the position of that white band relative to the surface of the model. If you shift the second value, which represents the V coordinate in texture space, you can make the whole white band move up or down in the preview window. And it would be super cool if we could animate this in a cycle. Now in this case, it would be fine if it's just increasing, it'll loop around by itself. In the last video, we learned how we can use the time node, and that would apply here. Input basic time, and let's connect this to the offset port. All right, but not so fast. Because this value of time is a vector 1, we want to make sure that we're only affecting the up-down direction. If you connect this as is, the vector 1 will populate both fields. Now you really can't see it in this case, but the white band is moving sideways in addition to moving downward. Now in the event you have some pattern that is something other than a straight horizontal line, we'll probably need to fix that. So let's restrict the time to only the second coordinate. We'll get rid of this line, and we'll drop in a vector 2 node in here, input basic, vector 2, and then we're only going to connect the time into the second value of the vector 2. So leave the first value at 0, since we don't want it to move sideways in the U direction. We only want the scanlines to move in the V direction. Then we'll connect the vector 2's output into the offset port. And voila, our white band is moving vertically in the preview window and not sideways at all. And that sort of looks like a scan line that you might see in an old television set or oscilloscope. and maybe you've seen some kind of equipment that uses that scanline rendering. Anyway, we might as well insert an extra control in here to adjust the speed. We'll add a multiply node in here. Math basic multiply. So let's disconnect this line again and just connect the time node to the multiply and then the multiply to the vector 2. Let's expose this as a property. I'll create a new vector 1 property on the blackboard. And let's name it scan speed, so we know it modifies the scanline texture. And default it to 1, it shouldn't be too fast. And let's drag that into the shader graph and connect that into the multiply input. And there you go, that should be a good stopping point to check what we've done. Save the asset, and let's see what our force field looks like with this shader. Okay, not too bad, that's the idea. Maybe our scan speed should be a bit slower. Let's try 0.5. With just the time node and that offset input, we now have a texture that appears to move downward across the surface of our sphere. I probably want to expose the tiling of these scan lines as well. So let's go back to the shader graph. Add a vector 1 property to the blackboard. I'll call mine scan size, default it to 1. And if you want to turn this into a slider, we can just choose slider from the mode dropdown. Min of 0 and max of 1 is about right. And let's drag this property into the shader graph. Again, we don't want to connect the vector 1 directly into the tiling input port, which takes 2 numbers. Let's create a vector 2 node. Then connect the scan size into the second value, and then connect this vector 2 into the tiling. Now it shouldn't matter too much for this particular texture since it's just a horizontal stripe, but we want to leave open the possibility of using any seamless texture in here. In this particular case, we're affecting only the vertical size of the ramp texture, so we're only adjusting the second field. All right, let's save the asset and try it out in the editor. At this point, you want to experiment with the settings and get a look that works for you. If you edit the rim color, you can pump up the intensity. Then our force field will glow a bit more in the post-processing. It begins to look more like a force field. And we can, of course, adjust the scan size and scan speed properties that we just set up. If you use a value of 0.5 for both, that sort of works. It sort of looks like this. And that's not too bad for how long we spent on it. It's starting to look like a sci-fi force field that you would expect to find in a video game. At this point, what you want to do is just keep experimenting with the textures and the settings. It's quite possible to make something that looks completely different than what we have. For the scanline texture, you can make the fill pattern look more interesting if you add some more horizontal lines to the ramp. I already have an alternate texture called Ramp Alt 64 by 256. If you import that and use that as the scanline texture, that gives you some extra flashes of those hex tiles. Of course, don't feel like you have to limit yourself to straight lines. You can use any texture in here as long as it's seamless. So just make sure that in Photoshop, the texture is perfectly tileable. So I hope you agree that this is a nice starting point for a force field effect. Try it out on different pieces of geometry and then customize the effect to your liking. The material works on any 3D object, but the rim glow is limited to the polygons that are at a grazing angle to the camera, so just bear that in mind. Here are some other objects from the sample scene with the force field matte material applied. You can almost make them look like holograms or something like that. Again, try different textures for the fill pattern or scanline, and then just have fun with it. And don't forget to post some of the cool stuff that you've been working on in the forums. You can always share a link to a YouTube video or something that shows a shader in motion. We'd love to see what you can make with this stuff. Okay, until the next one, have fun in SHADERGRAPH.